Okay, for the first problem of the virtual day assignment, it asks for each of g of -1, g prime of -1, and g double prime of -1, and we have to find all the values and state if it does not exist. So, for g of -1, what you have to do is find the area under the curve. So what I did was I made a dotted line from -4 and a dotted line from -1 to represent the area under the curve. Then I separated into two parts to make it simple. So I made a rectangle and then a triangle. And as you can see, you get 2 times 3 because the width is 3, length is 2. And for the triangle, it's 1 and 3 because the height is 3, the width is 1, and divided by 2 because that's the equation. And then you add it all together, you get 7.5, and since it's under the curve, you make it negative. Next, for g prime of 2, since the graph of f is g of prime and g double prime is f of prime, I just made that sure in here to make sure that I know what I'm dealing with. So all you have to do is look at the graph and see at -1 it equals -2. So that's going to be your answer. So for g double prime -1, usually what you would do is find the slope at the point, but since it's a corner, you get does not exist because at corners it does not exist. So for b, for the function g defined in part A, find the x-coordinate of each point of inflection of the graph of g on the open interval -4 is greater than x and is greater than 3. And explain your reasoning. So for this, I got x equals 1 because the slope of the graph changes from positive to negative at that point. So as you can see, the slope is increasing, hits this point, but it's still increasing, so no point of inflection. Increasing, well, it's positive, and then from here, now it goes negative. So the slope goes from positive to negative, which creates a point of inflection at 1. Next one, for part C, let h be the function given by h of x, and find all the values of x in the closed interval -4 is greater than or equal to x and greater than or equal to 3, for which h of x equals 0. So for this one, I just looked at the graph and found the area under each point under the curve. So as you can see, you can easily tell that when you're going to 3, the part on the left side has to be at least -1 because you're going to get -1 plus 1 plus 1, which is going to get negative. So it's going to be +1 and then subtract by the -1 since that's your equation. So as you can see, all this part from -4 to -2 is just not going to work because it would just be too negative to equal 0. So then you can start at -1, and when you plug it into the equation, you can see you get 0. And then for your next part, I tried to do at 1. I tried to do at 0, but you can't do that since it's going to be 1 plus 1 minus 1, which is going to give you +1, which does not work. So then my next part I did at 1, and as you can see, you get 0 because you get 1 minus 1, so 0. And then you know at the point itself, so at 3, you'll get 0 because it hasn't moved anywhere. Okay, for the last part, for each function f is defined in part C, find all the intervals on which h is decreasing. Explain your reasoning. So I said between intervals -4 to 0 and union 2 to 3, and it is decreasing between those intervals because the graph is below the x-axis, which means the original graph is decreasing. So as you can see, the graph decreasing, it was decreasing because it's below the x-axis, then hits this point, and then starts increasing, and that creates a minimum. So increasing, and then right here is a maximum, You don't need to know that, but just in case. So you don't have to worry about this part because it's above the x-axis, which means it's increasing. So decreasing, and then it comes to this point which reaches the maximum, and then it decreases again from 2 to 3. So that is it for the virtual day.